Hi, I'm Matt. Welcome back to another in-home repair video brought to you by ApplianceVideo.com. Stop. Before beginning any repair, always be sure to disconnect the power to the appliance. It is also recommended to test the outlet for proper voltage. Hi, I'm Matt with ApplianceVideo.com. Today we're taking a look at this SubZero built-in refrigerator. The customer's complaint is that it's just warm inside, not cooling at all. So what we're gonna do here first is just gonna open the door and take a look. And as you can see here on the temperature display, it's reading 70 degrees, which is obviously not even close to normal operating temps. You should be around 37, 38 degrees. It's set right now for 36 degrees. So the first thing we're gonna do here is we're just gonna check pressures. Tools you will need to complete this repair are a vacuum pump, a reclaimer, a reclaim tank, digital or analog gauges, a digital scale, oxygen acetylene torches, a filter dryer, a 3/16 coupler, emery cloth, brazing rods, a tank of R134A refrigerant, gas leak detector bubbles, wire strippers, needle nose pliers, channel lock pliers, a Phillips screwdriver, an inspection mirror, and a laser thermometer. Okay, so what we've done now is we've just removed our bottom access panel just to gain access to check pressures. So what we're gonna do here is we're gonna hook our low side up to the compressor, the suction line, remove the cap, all right, and now we're gonna go ahead and hook up to our high side here. Go ahead and turn our gauges on. And you can see here, we are actually in a vacuum. So this unit should be running at a 70-degree ambient temp, between 18 and 22 pounds suction, and roughly somewhere around 125 pounds head pressure on the high side. So we definitely have a leak in the system. This is, again, just a medium temp compressor because it's refrigerator only, so it should be reading between 18 and 22 pounds suction pressure. So now what we're gonna do is we're gonna see if we can actually find the leak. The easiest way to do this will be pulling the evaporator cover off, and we're just gonna add a little bit of refrigerant and see if we can find a leak. To gain access to the evaporator, we've got all of our shelves removed. The first thing we're gonna do is we're gonna pull the light cover off here. You got two tabs, one on each side, and you just get up with your finger, pop the tabs down, and then you're going to pull towards you just a little bit and release it from the tracks. You can see there how it actually hangs onto the tracks, and then this kind of comes up to lock the panel in place. All right, so there's just 3 Phillips screws here that are securing the back panel on. I'm gonna go ahead and take those out. Once those are removed, just grab the panel at the top, Just sort of fold it down, and then you're just going to lift it straight up and off. There's 2 tabs at the bottom that it sits on. And we're going to set this off to the side. Okay, so before we add any gas, what we're going to do is we're going to just kind of peel back some of this insul tube here. Looks like somebody's done some service work on this before because the insul tube was cut. But we're just going to peel it back a little bit. That way we've got access to these braze joints here. Sometimes just from the vibration and rubbing, you can get leaks here, you know, in your cap tube. So what we're going to do now is we're going to go ahead and add a little bit of gas and see if we can find the leak. Could be somewhere here, could be in the evaporator. If we don't find any leaks, then we'd be looking at the condenser, checking down there to see if we've got any leaks down below. So now we've got our tanker refrigerant. This does take our 134A. We've already got our low side still hooked up. So we're going to go ahead and hook our tank up. Again, it is our 134A for this unit. Go ahead and open the tank. Okay, now that we've got the tank open, what we're going to do is we're just going to purge the air out of the line. So we're just going to crack the line here, the yellow one. Just to purge the air out, that way we're not introducing any additional air into the system. So what you want to do with the unit off, you want to charge it up to about 50 psi equalized pressure to properly check for leaks. So we're just going to go ahead and charge it up to about 50 pounds, and we're going to leak check. Okay, we've got the unit charged up to 50 psi equalized pressure. We're just going to use gas leak detector bubbles here, and we are going to just check the fittings on the evaporator and see if we can find any leaks at any of these braze joints here or on the actual cap tube itself. We're just going to go ahead and saturate. And I can actually hear refrigerant leaking out. You can see it's bubbling up right here on the actual cap tube. So we've got a very small pinhole leak right here on the capillary tube, probably just caused by vibration. So you can get in here with an inspection mirror, get a look at the back side. That's the only leak that I'm seeing on the unit. The rest of these joints look fine. So what we can do is we can actually repair that leak by putting a little coupler in on the capillary tube. The proper way to repair this would be actually replacing the heat exchanger. If your hole was a little bit closer where you had enough cap tube to actually unbraze it from the evaporator, then you could just take the good part, stuff it down into the evaporator and rebraze the unit shut. But with the leak being this low, we don't have enough of the capillary tube to actually get it back into the evaporator. So we are going to have to put a little coupler right here. So just another mention, basically at this point, the proper way to repair this in the field would be replacing the actual heat exchanger. This is my personal unit here, so it's just going to be a garage refrigerator for me. We're just going to basically cut this tube and put a coupler in. It will be a permanent fix. It'll function just fine. This is just something that we're going to share with you on kind of an easy way to repair a leak. While we've got the refrigerant in there and we still know where the leak is at exactly, we're going to go in and just score the cap tube on either side of where the leak is at. We're not going to cut through it completely yet. So now we've got our spot marked here. What we're going to do is we're going to go ahead and reclaim the refrigerant that is in the system so it can be disposed of properly. Now that we have the refrigerant reclaimed, we're going to go ahead and cut the cap tube. Just kind of gently score it back and forth. So we know where our spot's at here, and we're gonna actually just cut right through the center where the leak was at originally anyways. So now we've got our two little ends there. Just gonna go ahead and grab it and kind of just wiggle it back and forth. So I switched over to a pair of needle nose pliers. I don't want to crimp this tube too much, but I wanted to get a good grasp on it. Just basically twist it and break it right off. And you can take a look in there, make sure it's not restricted or pinched at all. We're going to do the same thing on the other part of the tube. Just break it right off. So now all we have to do is just fill this gap with a coupler. All right, so now what we're gonna do is we're gonna clean up the cap tube so we can get a good clean braze joint. On the bottom one here, we're gonna just go ahead and sort of bend that down. That way when you're sanding, the particles will fall away and you won't get any contaminants into the actual cap tube itself. So you just want to make sure it's good and shiny and looks clean. And we're going to do the same thing on the top one here. All right, just going to bend it into position. All right, so we've just got our 3/16 coupler here. We've got this all cleaned up already. What we're going to do is we're going to just put this down about 1/4 of an inch onto the actual cap tube. So roughly about that much there. And then we're just going to take a pair of pliers. We're just going to crimp it down, just like that. Kind of have it a little bit off to one side. That way you'll be able to fill it. And when you're crimping it down, you're not going to close the cap tube off. And we're going to do the same thing with the top here. So what we're going to do here before we put the top one in, so we're going to go in with a flashlight, look from the top, and you can see the actual cap tube, and just basically making sure that it's inserted far enough and it's not crimped down, which it looks fine. So now we're going to go ahead and do the same thing on the top. Just going to crimp that down. Just like that. And now we're ready to braze the joint. So what we're going to use here are Dynaflow brazing rods. They're good for copper or silver. They do have the flux already built into them, so they are an acceptable material for this repair. Okay, so we've got our oxygen acetylene torches here. We're just going to go ahead and start on the bottom.
Let's keep going, but I can't really see over your shoulder.
And we're going to just go ahead and fill this bottom joint first. We do have a fireproof blanket as a heat shield on the back wall to prevent any damage to the liner. And we're just going to go ahead and fill the top joint. And now we're going to get a visual inspection on the joint, make sure it looks like it's all closed up. All right, so now we're just going to get a good visual inspection on the joints. Make sure we don't see any gapping where the joint didn't get filled properly. But this joint looks good, so we're going to go ahead and charge the system up. Now that we've got a repair made, what we did was we just replaced the filter dryer on here. Anytime you do any type of a sealed system repair, you always want to replace the filter dryer. That's going to filter out any contaminants, any moisture that's gotten into the system. So we've got that done here. Now we're going to go ahead. We still have our low side hooked up. So now what we're going to do is we're going to go ahead and hook our high side up to the filter dryer. Okay, we've got our low side hooked up still. So now we're going to take basically just the middle port on the gauges, and we're going to hook that up to our vacuum pump here. And we're going to turn it on, and we're going to open both valves. And we're just going to basically let that pull down into a 30-inch vacuum, and we're going to let this run for about 30 minutes. And that's going to remove any moisture, contaminants that are in the system. Okay, so we've had our vacuum pump running for about a half hour now. What we're going to do is we're going to close both valves, and we're in about a 30-inch vacuum here on both sides. I'm going to turn the pump off, and a good idea would just be to wait about 15-20 minutes, something like that, just to make sure that the unit holds the vacuum. And if it does, that's a pretty good indication that you're not going to have any leaks when you go to recharge it. Okay, so we've waited 20 minutes. We're still holding the vacuum pretty much the same way it was when we closed the valves off. So now we're going to go ahead, we're going to look at the tag and figure out how much refrigerant this takes and recharge it. All right, so we're at our model and serial tag here. It's a 601 series. You look right there, the refrigerator charge from the factory is 10 ounces. So we are going to actually charge it up to 10.5 ounces. We always do just basically a half ounce for line loss. All right, so we've got our tank here sitting on the scale. We're going to go ahead and hook up our yellow line to the tank. And we still have our high and our low sides hooked up to the compressor. So what we're going to do is we're going to go ahead and open the tank. Make sure both of your valves are closed. Go ahead and open the tank. We're going to go ahead and purge the line, the yellow line here, get the air out. Now what I like to do is take something pretty heavy and put it on your refrigerant line. That way, if the line gets bumped, it's not going to throw your scale off. And you'll get an accurate charge that way. I'm going to go ahead and turn the scale on. And we're just going to go ahead and zero it out. And what we're going to charge, again, is going to be 10.5 ounces. We're going to account for 1/2 ounce of line loss. So now we're going to take the gauges and we're going to charge off the low side here. So we're going to open the valve. What's going to happen is this is not going to probably want to take the refrigerant, or if it does, it'll take a long time. So what we're going to do at this point, we'll close the valve here. We're going to go ahead and power the unit up. That way the compressor will pull refrigerant. So we'll go ahead and crack the valve back open. Alright, so you can see we are charged up 10.5 ounces of refrigerant. So now what we're going to do is we're going to go ahead and close the tank. And we're just going to go ahead and open up our low side one more time. And that will pull any remaining refrigerant in the lines into the system. Go ahead and close that off. So now what we're going to do is we're just going to leak check our joint and basically make sure that we don't see any bubbles. Alright, so what we're going to do before we button it up here is we're just going to check for leaks. At our 2 brace joints here. And it looks good. Don't see any bubbles forming. Alright, so now we're just going to go ahead and kind of button everything up here. Just gently bend back the tube here. And we're going to put our insul tube back around it. And just using electrical tape. Doesn't really have to be perfect, but be a good idea just to get this wrapped. Alright, now that that's all buttoned up, we can go ahead and put our back cover panel back on. Alright, now we got our back panel here. Just gonna go ahead and sort of angle it down. Got 2 little slots that it's going to drop in on, and then just roll it forward. You want to make sure that this is flush, because if it's sticking out at all, your shelves aren't going to want to go in right. We'll get our screw in up at the top here in the middle. The other 2. now we're ready to put our light cover in. So with the light cover, you got your little locking tabs here. Those are going to go towards the front. So make sure they're both opened. And come up. Once it's dropped in, push it to the back. Now you're just going to roll your locking tabs over to secure it in place. All right, now we're just going to go ahead and disconnect our high and low side lines. And put our caps back on. And we're just going to kind of tuck the filter dryer back up in here so that the access panel can go back on all right. Basically what we're going to do is just give it 24 hours. We're going to put some bottles of water in here, and then we're just going to check the temperatures tomorrow just to make sure it's maintaining proper temps. All right, we've had this unit plugged in for about a day now. We've got this bottle of water in here. We're just checking temps. And we're reading 38.2 degrees. Basically, you're looking for really anything between 38 and 42 degrees is going to be normal operating temperatures for this unit. And all we need to do is just put our kick plate back on, and that's going to complete the repair. Thank you for watching another quality video brought to you by ApplianceVideo.com.